thank you all for staying here. I know it's a really beautiful day outside in Greenwich, and so thank you for your patience in being here. So I want to say a few words about what I see as to be a very interesting aspect of the side debate and regarding the standards. And that is to say, from the way I read the literature, as far as science is concerned, it really doesn't seem to be standards. That is to say that one might sort of go through the exercise of doing lots of experiments across different laboratories. You might get a meta-study, and generally not getting much in the way of widespread acceptance. Okay, and I think we're all sort of familiar with this general idea, and also, though, I think it also goes into various kinds of arguments that people have used that basically probably wouldn't make arguments against side probably wouldn't be made with more conventional in conventional sort of issues. So let's see, and I think that so basically the idea, and Richard Wiseman and Christopher French, they're fairly moderate skeptics. So and arguably they are sort of like looking at the data, thinking about it very carefully. So yeah, they're saying there's something very controversial or radical about psi that means that we really shouldn't probably maybe take it too seriously. So so there's this idea that there's something controversial, radical about psi. Now, Jim Carpenter had a very interesting talk last night about how maybe psi is not radical, maybe it's very ordinary. And so maybe we can think about psi as being we can sort of question, is it really something radical? Well, what is radical? What is controversial? Well, there's all kinds of things, in my opinion, that are debated in science. For example, there's the Everett mini-worlds interpretation that every quantum mechanical possibility is realized, even though we don't really observe it. This is something that mainstream scientists present at mainstream conferences, get publications in mainstream journals, and get tendered for. We could sort of like look at other examples. Artificial intelligence becoming conscious, consciousness uploading into some sort of like cloud at some point. There's all kinds of very sort of mainstream ideas that are back and forth. It's true that they're controversial in a sense, but they still get kind of like mainstream attention in a way I think that psi doesn't. So I kind of so I think it's kind of an interesting question. Now so now there are obviously times where it's necessary that that we have some reason to believe that the experiment was maybe there's some sort of mistakes involved, some sort of fraud, maybe some sort of X factor that we really don't that we really can't. And it just seems really funny. So I'm not really saying that we shouldn't take a very skeptical view of a lot of kinds of experiments, but I'm just saying that maybe we have to sort of look at the other side of it too a little bit. Is it possible that certain types of arguments used by skeptics are just simply moving the goalposts? Shouldn't we be a little bit more worried about type 2 errors? And what about the cost of ambiguity of the standards? Is it really the case that can you think of a test that will convince most skeptics in a way that would generate widespread acceptance? I'm not sure I can. So does this ambiguity of standards, does it lead to sort of psi always being kind of in limbo or in sort of a doghouse, so to speak? Does it mean that researchers will be discouraged from looking into it? Perhaps never really, academic departments never really taking it seriously. So I just want to sort of point out that although there are good reasons to sort of like apply a very skeptical take on a lot of these kinds of things, we need to think about the cost too. So one way to maybe think of a more sort of rigorous foundation for, let's say, to think about controversy or something that's, maybe more skeptical is to take a Bayesian approach. And a lot of people are doing this. People are doing this more, and I think it has a lot of, it's a way to maybe formally try to put in arguments about, our worldview or maybe our metaphysical metaphysical assumptions that might, maybe, but there are certain problems with it too, perhaps, in that while we can obviously, let's see, okay, you have your prior. That allows you to sort of like maybe in some sense formally discount the evidence. But of course it gives you a lot of leeway too to kind of like create whatever it may be that you could sufficiently, no matter what the evidence is, if you select your prior low enough that you'll still never get to where you're accepting the data. So you've got to be, so although Bayesian approach might be a good way to kind of like sort of more formalized skeptical arguments, there still seems to be a lot of wiggle room. So anyway, there's we might want to think about paradigms, as I think everyone here is pretty familiar with. Kuhn's paradigm, notion of a paradigm, is a sort of a very useful construct in the way it sort of constrains research in what Kuhn called normal science, and in this way organizes researchers to focus on ideas that sort of like generate sort of payoff, and obviously constrain research. Sort of the paradigm according to Kuhn, you have your sort of like your dominant theories, you have your influential experiments that probably paved the way for a lot of those theories. You have your sort of acceptable methodology, and you might, and this doesn't always get as much attention, but this is also important, your metaphysical assumptions, your assumptions that you're not really testing, but you sort of need some assumptions about maybe background reality or something in order to get your theoretical framework off the ground. So the philosophers of science, Henderson, Goodman, Tenenbaum, and Woodward, have an interesting framework, and this is very similar to Professor Potts's Bayesian equation yesterday. He put up almost the exact same thing, only instead of T0, he just simply put in sort of the worldview, or maybe what we think of as sort of the background knowledge. So we can think of, so what I'm doing though is I'm sort of following Henderson et al.'s framework, is what they have, a hierarchical Bayesian model, where they sort of like try to incorporate the idea of a paradigm in sort of your Bayesian framework. So this is just my thinking of trying to isolate what might be sort of formally at the root of a lot of these kinds of debates. And obviously, this is a real important one here, how the paradigm is influencing your prior. So it could well be that given your paradigm, you might be constrained to simply not accept certain types of evidence, no matter how much evidence is. But at some point, at least in theory, if you get a lot of evidence, you might want to get to a point where you start to think, well, okay, do I have the right paradigm? Kuhn talked about how you might accumulate a lot of sort of anomalies in your experiments, and over time there may be some way we can think of, people might start to think of maybe expanding the paradigm, or and so forth. So this is something that we might be involved in here, I think. What I've done here in this argument is I've looked through some of the skeptical literature, and I've tried to sort of like think, okay, what might be at root, sort of maybe some sort of like assumptions or metaphysical kinds of thinking or what have you, that is really kind of constraining research in a way that would be discouraging them from accepting the side evidence. And now I'm not sure, it's not always sort of argued explicitly in this kind of framework, so I'm not really sure I've captured it. But basically, the way I read a lot of the skeptics, what I came up with, proper scientific theories that describe macroscopic events, that is outside of subatomic physics, should be consistent with currently well understood classical physics. So I'm not really sure that's the best one, but that's kind of the way I read a lot of the skeptics. So that's the one I'm sort of going with at the moment. Now this is actually a pretty good one, I think, in fairness, because after all, classical physics really does explain a lot. We have, it's an incredibly powerful sort of framework. But is it really sort of sufficient to, does this really this sort of like principle, would it really work to explain everything that we want to know about? And there's two areas that come to my mind. The way I've defined it, it's sort of obviously, probably doesn't work well with quantum mechanics. But also, consciousness is an area, and by consciousness I'm really referring to what David Chalmers calls the hard problem. That is that how to explain sort of the subjective inner experience. Okay, now, do we really think that our body of knowledge is really going to kind of like sort of solve this? This is something that I think a lot of philosophers of the mind, completely outside of, who are not really involved in the side debate at all, have really started to sort of like step up and say, it really seems that there's something about the subjective nature of consciousness that is really very different from everything else we seem to know. So again, this is sort of the problem of consciousness. And there really is no consensus agreement across scientists and philosophers for a theory of consciousness. There are theories of consciousness, but there's not one that's sort of where everyone gets behind and says, yeah, we have a lot of confidence in this. Also, the theories of consciousness that we have are not really grounded in established laws of physics. There's nothing about the laws of physics that we have that really would sort of like indicate or even remotely hint why collections of particles might become conscious. Okay? And so, and a big problem is this one here. Making progress on consciousness is very problematic because of the inherent subjectivity of the data. I'm pretty sure that I am conscious, and I'm pretty sure that you are too. But at the same time, I don't really know how to sort of like see where we draw the line, and I think that's really a big problem. Where do we see how consciousness might emerge? How can we develop a really good theory of consciousness without, if we're not really able to sort of like see the data, or at least gather data in an objective way? So, as I mentioned, David Chalmers has been very influential in bringing this to a lot of people's attention. And I think this is a very interesting quote that he gave last year at a TED Talk, and so I'm going to read this. He says, "I think consciousness right now is a kind of anomaly, one that we need to integrate into our view of the world, but we don't yet see how. Faced with an anomaly like this, radical ideas may be needed. And I think that we may need one or two ideas that initially seem crazy before we can come to grips with consciousness scientifically." Okay? So, if you sympathize or agree with this, it seems like we really don't have a good foundation for sort of dismissing data that's intimately linked with consciousness that is kind of surprising, or sort of, let's say, counterintuitive or anomalous. Okay? And it's worth pointing out that one of the key points in a lot of skeptics' arguments is that psi is really just outside of everything we know in science. It's just like outside. It can't be true because it just doesn't fit into the framework. But they really don't come to terms, I think, with the idea that consciousness itself is not really, we can't really generate consciousness in that framework. At least we haven't so far. Now, a lot of people don't agree with this. I mean, I don't think that that a consensus of scientists feel this way. But let's think about how we might try to explain consciousness with more conventional or ways of thinking, conventional ways of thinking. Okay? Now, how would we fit consciousness into the laws of physics that we currently have on the books? Let's remember that the laws of physics are mathematical relationships between mass, energy, frequency, spin, velocity, and so forth. Now, how is consciousness supposed to fit into that framework? How are we supposed to it really seems like I'm not even aware of one person on the planet who's really trying to think about how consciousness fits into that. It seems like it's pretty much a categorical error, and that's what leads people like consciousness to sort of and Nagel and others to argue that consciousness is most likely something that's fundamental, something that doesn't emerge from let's say, collections of subatomic particles in some way. Given those kinds of statements, though, I would argue that emergence of consciousness would be far more radical than any other emergence that we are aware of. And again, the problem is, how would we observe that? How would we test that kind of thing? If we, how would we observe consciousness emerging from non-conscious particles, given the inherent subjective nature of it? So let's consider the possibility that David Chalmers and others might be onto something, and we want to think about what to do about this. Now, Kuhn doesn't really give us clear indications on how a field, knowing how a field is in some sort of crisis that will lead soon to a new paradigm. However, David Chalmers' statement is pretty close to something like that. He's very unequivocal about the fact that business as usual is not going to probably get us to a really good theory of consciousness. So okay, we say, well, okay, what do? What's the next step? Well, as I said, establishing a theory of consciousness is problematic due to the inherently subjective nature. So, however, if we take Chalmers' statement and say, okay, what if we have a way to collect data that is objective, yet recognizing that consciousness is anomalous in some sense, so therefore this data would capture some aspects of anomalous nature of consciousness, yet we're very careful in doing laboratory studies and so forth, then we might be on the way to build a theory of consciousness. However, we actually have that set of data. That's the psi data. So the psi data, perhaps in a different way of looking at it, is not this anomalous data. It's actually data that we need to really kind of like, to really sort of like truly understand consciousness. If Chalmers and other philosophers of mind are correct. So anyway, it may well be that we might be better, instead of having some sort of like sort of paradigm, as I mentioned, we might be better off just sort of like looking at the data, using some reasonable prior, of course, but letting the data inform us so that we can sort of like basically I think come to a probably I think basically treating the data inside not so much different from the way we do with other more conventional. Now, I'm not saying that we shouldn't use very strict standards. We should be very careful. I think we should do that always with all data, with all conventional areas of psychology. But I don't really see a strong justification for applying a different standard of psi, given the sort of like the perhaps limitations that I think a lot of the paradigm seems to have, especially in support areas. Hello, Nathan. So Nathan's getting. So let me try to wrap up. Just a few key ideas here. First of all, if we have no theory of consciousness, do we really have a basis for dismissing data concerning consciousness that is surprising, counterintuitive, or anomalous? And secondly, making progress in consciousness as a separate sort of thing that's obviously very important, might require a crazy idea. And my vote for crazy idea is, let's kind of be open about the data we are collecting with respect to consciousness. By open, I mean let's not impose. Let's be very careful about not imposing any more than we have to additional kinds of hurdles and standards. So I think that's it for me. Thank you very much.